You've probably seen Venus yourself. After the moon, it's often the brightest thing up there in the night sky. We call it Earth's sister planet, this beautiful, familiar beacon. But here's the thing. That family resemblance, it's one of the biggest deceptions in the entire solar system. This is the story of a sibling that took a very, very different path.
Yeah, and this quote just nails it. It perfectly captures the absolute shock scientists felt as they started to peel back the layers of this world. It turns out the closer we looked at our supposed twin, the more we realized we didn't know this planet at all. It was a complete stranger.
And you can totally see why we got that idea at first. I mean, look at the numbers. They're almost the same size, almost the same mass. If you could somehow stand on the surface of Venus, you'd only feel about 10% lighter. So on paper, they look like twins. This is what built that whole sister planet idea.
Right? So that's the big question. If the basic stats look so similar, how different can they really be? Well, as it turns out, the answer is pretty much everything else.
Okay, so the first clue that something is way off with Venus is just how it moves. For starters, unlike almost every other planet, it spins backwards. And it spins so slowly. Get this, and this is wild. A single day on Venus lasts longer than its entire year. You would literally celebrate your next birthday before the sun finished rising and setting once. Just bizarre.
But the weird spin is nothing compared to the planet's most obvious feature, its atmosphere. Those thick yellowish clouds you see in pictures aren't just weather. They are a permanent, suffocating blanket of mystery that for decades completely blocked our view. We had no idea what was hiding underneath.
So, you've got this mystery world wrapped in clouds. How do you find out what's going on down there? Well, during the space race, the Soviet Union's Venera program had a very direct solution, a brute force approach, you might say. They decided to just punch right through it. So let's imagine we're on one of these probes, falling through the layers. At first, you hit the upper haze, and it's pretty calm, deceptively so. Then, bam! You plunge into a 20-kilometer-thick nightmare of pure sulfuric acid clouds. We're talking battery acid. And deeper still, it gets even weirder. The air becomes so dense it's not really a gas anymore. It becomes a supercritical fluid. Imagine trying to swim through boiling hot sludge that's also trying to crush you. That's what it's like.
And as you get closer to the surface, the numbers just become insane. The temperature skyrockets to 464 degrees Celsius, hot enough to melt lead. The pressure is 92 times what it is on Earth, like being a kilometer deep in the ocean. It would crush a submarine. And why? It's all because the atmosphere is almost entirely carbon dioxide, creating the most powerful runaway greenhouse effect you can possibly imagine.
Now, unbelievably, a few of these Venera probes actually survived long enough to land, but their lives were short. They'd send back these haunting, yellowish pictures of a flat, rocky wasteland, and then silence. The planet would cook and crush them, usually in under 2 hours. So even after landing, the true face of Venus was still a total mystery.
So, dive bombing through the atmosphere gave us some incredible data, but it wasn't going to give us a map of the world. To really see Venus, we needed a different approach. We needed a technological superpower. And that's exactly what we got with NASA's Magellan mission.
And that superpower was radar. You see, a regular camera can't see through those thick clouds, just like your eyes can't see through a wall. But radar signals can. They slice right through the atmosphere, bounce off the solid ground below, and return to the spacecraft, allowing it to paint a detailed picture of the hidden landscape.
And wow, did it work! In the early 90s, Magellan orbited Venus for years, pinging its surface with radar over and over again. And the result? It mapped 98% of the entire planet. For the first time in history, the veil was completely lifted. We could finally see Venus.
So, what did Magellan find hiding beneath those clouds? Well, it sure wasn't Earth's twin. It was a world that had been absolutely forged in fire. The data just screamed volcanism. A staggering 85% of the surface is just covered in ancient volcanic rock. And you notice something else. There are almost no impact craters. That's a huge clue. It tells us the surface is geologically young, meaning the entire planet must have been repaved by lava again and again.
And the volcanoes there are just plain weird. You get these things called pancake domes, which look exactly like they sound. Flat, round volcanoes made from thick, sluggish lava. You get giant shield volcanoes like Mont Mons, which is nearly as tall as Mount Everest. And then you get these truly unique features called coronae. These giant circular fractures where plumes of magma have pushed up the crust from below.
So, why is Venus a volcanic world and Earth isn't? The answer is plate tectonics, or rather, the lack of it. Here on Earth, our crust is broken into moving plates that act like a giant thermostat for the planet, recycling carbon and releasing heat. Venus doesn't have that. Its crust is one single solid piece, a stagnant lid with no release valve.
And when you don't have a release valve, pressure just builds and builds. For hundreds of millions of years, heat gets trapped under that solid crust until everything fails catastrophically. The entire planet's surface overturns in a global volcanic event. We think this is exactly what happened about 300 to 500 million years ago, creating the young, lava-covered surface we see today.
So mapping the whole planet didn't solve the mystery of Venus. Not at all. In fact, it just opened up a whole new can of worms, a new set of even more fascinating questions.
Probably the biggest question is about its past. If it really did start out so much like Earth, is it possible that billions of years ago, Venus was a blue world? Could it have had liquid water oceans? Could it have been habitable before something went terribly wrong with its climate?
And that leads to the wildest question of all. Could life exist there now? The surface is obviously a no-go, but high up, about 50 kilometers into the clouds, there's a thin layer where the temperature and pressure are surprisingly Earth-like. A few years ago, there was a controversial report of phosphine gas in that very layer, a gas that on Earth is linked to life. It's heavily debated for sure, but it has ignited this fierce discussion about whether tiny microbes could be floating in the clouds of Venus.
All of this has sparked a true renaissance in Venus exploration. After decades of focusing on Mars, we're finally turning back to our other neighbor. NASA and other space agencies are now planning a whole fleet of new missions for the 2030s. Missions like Veritas and Da Vinci are being designed right now specifically to go back and solve these mysteries about its ancient oceans, its wild geology, and maybe, just maybe, what's going on in those clouds.
And that really leaves us with the ultimate question. The story of Venus isn't just about a distant planet. It's a cautionary tale for us. It forces us to ask, what's the tipping point? What's the subtle difference that sends one planet down the path to becoming a garden and another down the path to becoming an inferno? Understanding what happened to Venus, in a very real way, is critical to understanding the future of Earth.